Okay, the 7.3 quick check. The first one says the volume of the container is changed from 2 liters to 1 liter. What is the stress? Okay, the stress here is that there is not enough volume, not enough space. Okay, that we're squeezing this down from 2 liters to 1 liter. You might also say there's too much pressure. Now that's going to make a difference in this case because on this side we have 4 moles of gas. And on the other side, we only have 2 moles of gas. And we learned a long time ago that, every gas takes up the same amount of room. So if there's not enough volume, okay, it's going to be able to shift over to the side with fewer moles of gas. But the question is, what's the stress? The stress, there's not enough room or there's too much pressure. Now, Le Chatelier's principle, okay, determine the direction of each shift. So I'm going to announce what is the stress, figure out the shift, and then figure out what's going to happen to the amounts of each substance. Okay, so if I add SO2, there's too much SO2. If there's too much SO2, I'm going to shift away, use up the SO2. So this is going to go down, this is going to go up, and because I added the SO2, it's going to go up. It's going to go down because it shifts left, but it never completely uses up what I make. If I add a catalyst, there's no shift, it just gets to the same equilibrium more quickly. If I remove O2, then there's not enough O2, so I'm going to shift back towards the O2 to make it up. So this is going to be up and this is going to be down, but whatever I remove goes down. I am going to make it, but it's not going to make back everything I used. Decrease the temperature, there's not enough heat. If there's not enough heat, I'm going to shift to the side that makes more heat, so this is going to go up and this is going to be down and this is going to be down. If I decrease the volume, there's not enough space, so I'm going to shift to the side that takes less room. And this side the left side has 2 moles of gas, the right side has 3 moles of gas, so I'm going to shift to the left. So this is going to go up, and this is going to go down, this is going to go down. Okay, second one, I'm going to add some O2. Add O2, there's too much O2, so I'm going to shift to the left. I'm sorry, okay, that's right. Okay, that'll use up my O2. So I'm going to add O2, so that's going up, okay, but the other two, since we said back here that we're asking what's going to happen to the amount of each substance, okay, well, this is going to go down and this is going to go up. If the question had been what happens to the concentrations, it would be no change, no change. Okay, if I add some mercury, okay, adding a liquid or a solid does not change the concentration, so it does not shift anything, so it's going to be no change, no change, no change, except it says you're going to add mercury, so I would say this actually goes up because you're adding it. Reduce the volume. Go to the side that takes less room. Well, this is 1 mole of a gas, but of this side there's 0 moles of gas. So the left side takes less room than the right side, so if I reduce the volume, that's the stress, is there's not enough room. It's going to shift to the side that takes less room. So this will be up, this will be down, and this is going to go down. Now we're going to remove some HGO. Again, adding or removing, okay, does not, there's no stress involved, there's no change. So it's going to be no change and no change. But since I remove some of my solid and it says what's going to happen to the amount, well, then that's going to go down because I'm removing it. Okay, but if the question had been, what is the concentration, I would have said no change, no change, no change all the way across. And that is the quick check.